Good morning and welcome to the third day of the NEAP scope presentations. My name is Martha Shields. For the past 6 or 7 years, I've been the technical project officer in the Small Modular Reactors program, administering cost-shared projects with our partners to advance the designs of SMRs and to ultimately get them sited, licensed, and ready for commercializations. As you can imagine, this is quite a bit different from the world of R&D and academia. I took over as the federal POC for the Hybrid Energy Systems program from my esteemed but recently retired colleague, Carl Sink, who many of you may know. The actual brains behind the HES program is INL's Dr. Shannon Bragg-Sitton, who is on the phone to answer your questions about the program. As a reliable, clean baseload supplier, nuclear energy needs to stay relevant by contributing. What? I did. Is it on the second slide? Okay. Nuclear power needs to stay relevant by contributing to the evolution of sustained balanced energy system, which consists of all of the above energy resources and energy partnerships to efficiently use all energy produced to make electricity or thermal energy for process use. The goal of the Hybrid Energy Systems program is to develop the tools to dynamically integrate nuclear power assets with other sources of energy and with industrial applications. Ultimately, this will allow nuclear power to be a part of maximizing the flexibility of the entire energy system while maintaining the advantages of nuclear economic performance, reliability, and resilience. The NE-R&D work ongoing in the HES program focuses on design and testing for optimization for hybrid systems architectures and other technology options to enable more efficient and environmentally and economically sustainable energy systems. Specifically, we perform modeling and simulation for tool development and associated analysis to make sure it is technically and economically viable. Also, to virtually optimize the systems to move the energy around. We also develop the physical dynamic interfaces connecting nuclear energy and the grid and industrial applications. Of particular interest is the development of a pressurized water reactor emulation system at the INL that will be coupled to the thermal energy distribution system to dispatch thermal energy to an electrolysis system to ultimately generate hydrogen. NE 2.1 scope includes studies of components and/or system degradation. We are looking for characterization of dynamic energy system behavior, which can include modeling and hardware in the loop. We are looking for it to capture real-time dynamic response behavior and determine the impact of thermal cycling on components and subsystems and the implication to the robustness of those components and systems, as well as to overall system aspects like resiliency, response rates, etc. NE 2.2 scope is cyber-informed system design for nuclear renewable hybrid energy systems. In this scope, we are looking for enhanced communications protocols that link grid operations by RTOs and ISOs to integrated energy systems operations. We want to make sure that data transmission is sufficient to support optimal energy dispatch. Specifically, work should include development of front-end controllers and associated control theory to support optimal dispatch of nuclear plant-generated thermal energy to either make electricity to the grid or go to support coupled non-grid processes. Cyber-informed engineering should be incorporated into the data transition and management, human monitoring and control performance, control signal processing, and device level control actions. Studies should include control hardware in the loop. And lastly, NE 2.3 scope includes system controls for nuclear renewable hybrid energy systems. This is modeling to better forecast the demand load in the supply to better predict where the energy, either electrical or thermal, is needed and how best to move it around. To this end, we need control technologies or approaches to be able to plan for the ultimate dispatch of energy, whether, again, to the electrical grid or to industrial applications. We are hopeful that the diverse expertise among university researchers will bring new ideas to HES design, optimization, and demonstration. We want the NEAP modeling and simulation scope to develop tools and techniques that address longer-term questions. The results and output will enhance ongoing HES modeling and simulation work. And again, we see it supporting longer-term needs, but they could be integrated into the laboratory toolset as soon as they are available. We will use them as a component of follow-on system design and testing, or to refine hardware-in-the-loop system design. Approaches must be compatible with the laboratory developed toolset to allow future integration, and these include Raven and Modelica. Deliverables should include modeling and simulation components that are ready to be integrated into the overall hybrid energy systems model architecture. So, are there any questions for Shannon?
Okay, welcome back to the final day of the CINR scope webinars. We will open up for questions. Please submit any questions you have to the GoToWebinar application. Submit those in writing and we will add Shannon. Shannon, can you hear us?
Yes, I can. Can you hear me?
Yes. So we have Shannon here to answer any of those questions. We'll wait over the next minute or two to receive any of those questions. Thanks. Are there any requirements to include uncertainties in the optimization algorithms?
That would be for Shannon. You want to repeat it?
Anything associated with the computational work, if uncertainties can be included in that, that would be desirable so that we can understand how good the simulation is relative to actual. So if we have some sort of quantification of uncertainties in that, that would be preferred. I wouldn't say it's an absolute requirement, but preferred.
Could a university propose with an actual nuclear power plant?
I'm sorry, Shannon, go ahead.
Oh, that's okay. Now, I had a similar clarification. I assume that that means that a partnership with a plant owner operator, absolutely within the constraints of the CINR calls of non-university entities only receiving up to 20%. But if there's a partner in industry that's operating a current plant, for instance, a plant that might be looking at repurposing or retrofitting, that would be a very strong proposal in partnership in moving forward.
Are there any CO2 related research focus areas?
I would say not specifically, but in optimizing these systems, reduction of emissions is part of the goal in looking at how we operate hybrid energy systems or integrated energy systems. However, this particular area under NE, we don't have a focus on CO2 research, so I'm not sure exactly what's being thought in that question, but including emissions as a part of the optimization is something that we do. Or utilization of CO2 in coupled applications could be a part of that as well. Perhaps that's where the question is going.
Will INL provide the benchmark system for demonstrating the developed approach?
We can provide certainly lists of, right now, lists of what we have already modeled and what that configuration looks like when we run through optimizations of integrated systems. If somebody is doing a research project, we can work through getting participation in the development framework. So some of what we work on has already gone open source. Others that are development are not yet open source, but we can certainly share some of that framework with individuals or universities that are doing development work on that same platform. So it's a matter of getting approvals run through the system to access the codes that we're working on. However, in advance of award, we are more than happy to provide reports and lists of what components are available in the overall structure.
Okay, I think that's all the questions we have. Thank you, Martha. Thank you, Shannon, for being here.